First, thank you very much for having invited me over. The title of my presentation is How Much Small Ruminants Are to Blame for Climate Change in Europe. The EU's agricultural sector accounted for 10% of the EU's total greenhouse gas emissions in 2015. Most emissions from agricultural sources come from enteric methane from ruminants and manure, and nitrous oxide from agricultural soils. In the last decades, greenhouse gas emissions from agriculture in the EU have decreased substantially, mainly due to a decline in nitrous oxide emissions from agricultural soils, driven by the reduced use of nitrogen fertilizers, as well as a decrease in methane enteric fermentation emissions caused by a drop in livestock numbers. Here we have an example of the evolution for methane emissions from sheep and goats in Europe since 1990. This shows an average reduction of about 3% emissions per year. As you can see in the following graph, sheep in Europe emit most of their direct greenhouse gas emissions in form of biogenic methane coming from rumen fermentation. They also produce, but in smaller amounts, methane in manure and nitrous oxide from different stages of manure management and grazing activity. But methane from ruminants is not the same as the greenhouse gases produced by combustion of fossil fuels. Let me explain why. While greenhouse gas emissions from industry and transport are caused by burning of CO2 fossil fuels, agriculture, including livestock, emits most of greenhouse gases in the form of biogenic methane and nitrous oxide. When we burn coal, we add CO2 to the atmosphere, and this CO2 lasts for hundreds of years, and therefore adds to the stock of CO2 already present in the atmosphere. But methane from ruminants is not the same as fossil fuels. Whereas greenhouse gases produced by coal and oil add CO2 to the atmosphere, and the CO2 lasts for hundreds of years, as we have already said, methane only lasts for about a decade in the atmosphere. So, when an animal belches methane, it does not necessarily add to the net atmospheric stock of methane, because methane does not last in the atmosphere for very long. Within a decade, this methane is converted back into CO2 directly used by photosynthesis to grow new grass, and this process repeats again and again. We have to point out that this CO2, we can consider it climatically neutral, as this is the CO2, the same type of CO2 that we would consider as the CO2 that we breathe or animals breathe. Whereas with the industry and transport, 100% of the emissions of carbon add new CO2 to the atmosphere and add this carbon that has been stored underground for millions and millions of years. Conceptually, we can think of the atmospheric stock of CO2 as a bathtub filled with water. The bath is the atmosphere, the water is the CO2 in the atmosphere, the inflow from the tap is the CO2 emissions, and its drain is the limited natural capacity to remove CO2 from the atmosphere. Before the Industrial Revolution, the inflow equaled the outflow, and the water level was stable. And so it was the atmospheric CO2 concentration. The Industrial Revolution tipped over the balance by increasing the inflow, therefore making the levels of atmospheric CO2 rise and rise, leading to the current warming of the Earth. In order to stabilize the CO2 in the atmosphere, we need to close the tap, which should require a fast transition to renewables and cutting down on energy consumption. Well, this concept partly explains what is happening currently. So why the biggest drop in CO2 emissions caused by COVID-19 is not reflecting on the levels of CO2 concentrations in the atmosphere. We have realized that we can turn down the tap in the bathtub, and you can see that there is less water coming in. But still, it takes a while to be able to see that the rising water level slows, and so does the level of CO2 in the atmosphere. So, as we already mentioned, methane from ruminants is a different story, because methane is rapidly reconverted into the cycle as CO2 for plants, and remember this CO2 is climatically neutral. We can consider that the water outflow is equal to the inflow. What goes in goes straight out. This will continue to be the case as long as we don't add more ruminants in the years to come, or we don't add extra emissions to come. So the main issue here is that methane is a short-lived gas, as we have already said before, and it only lasts about a decade in the atmosphere before it's converted back into this neutral CO2. And its warming potential then should be therefore considered differently from that from carbon dioxide from fossil fuels, which is a long-lived gas. Research by a global team of scientists based at the University of Oxford provides a new way of measuring the impacts of methane on global warming. They use a metric known as GWP, Global Warming Potential Asterisk. In this sense, in these graphs, we can see an example of greenhouse gases as global warming potential estimated by the conventional metric greenhouse water potential for a 100 years horizon, and this is in red, and the same emissions in green using the new metric. So when we try to link these metrics with real warming, we can see, and we see it in green, in this graph below, we can see that this new metric follows well the real warming expected in green. What it does not follow well is the conventional global warming potential for 100 horizon year, which is in red. So this new metric from the University of Oxford linking the emissions to warming makes it evident that these emissions that previously mentioned from sheep and goats' direct greenhouse gas emissions in Europe have caused no additional warming to the atmosphere in the last decades. This is mainly due to this reduction in this short-lived gas, methane. If we look then at the future, we can actually link specific pathways of reduction of greenhouse gas emissions to global warming for European sheep and goat systems. So here we have the resulting warming that would be caused if emissions from 2018 to 2100 are not changed. So there is some warming. So reducing greenhouse gas emissions will reduce the impact of sheep and goats on global warming. So for example, reducing 0.3% would still cause a little bit of emissions, but almost zero. If we reduce further, that means reduce below 0.4% annually our emissions per year. This will make the sector be climatic neutral in the period of time of this 21st century. We can actually reduce even further the emissions and therefore contributing to non-warming and potentially cooling effect. Here we can see until 2% reduction of emissions. So far we have been talking about direct greenhouse gas emissions from the sector. These emissions account for the greenhouse gas produced within the boundaries of the farm and are generally the emissions that are attributed to the sector in national greenhouse gas emissions and national greenhouse gas inventories. However, we can look beyond these boundaries of the sector and think as a life cycle analysis of the products. We then can consider the emissions arising along the supply chain from cradle to retail point. So those from the farm, but also pre and post farm gate. And here in these graphs, I show different carbon footprints for sheep and goat production systems, different production systems, grassland-based or mixed base for meat and milk production, milk and meat production. We can see that the carbon footprints of sheep and goat milk in Europe are still dominated by methane emissions. But also when we look at carbon footprint, we see that both CO2 and nitrous oxide are also important greenhouse gases used in these boundaries. The CO2 and nitrous oxide are mainly caused by feed production outside the farm limits and also by manufacturing of fertilizer. Just bear in mind in these graphs that the carbon footprint is expressed as kilogram CO2 equivalents per kilogram of protein produced. So these emissions arising along the supply chain from cradle to retail point have caused some level of warming, see left side graph. And this is some level of warming that is slightly larger because it considers, for example, CO2 from fossil fuels from transport, from feed production, etc., from fertilizer manufacturing. So it's larger, the contribution to warming, than if we use only direct greenhouse gas emissions as we have before estimated. And this is the right side graph. But this is not all of the story. So if we consider the emissions along the supply chain from cradle to retail point, we think it's a fair way to estimate the carbon footprint of milk or meat when we eat. So probably more fair than estimate only direct greenhouse gas emissions from the sector. So here we can have an example for milk, for the carbon footprint for milk produced in 12 sheep farms in the Basque Country. This is located in Spain. So we can see here that some farms, these 4 farms here, are fully house farm intensive, and they have lower carbon footprint than these other farms that are extensive and rely on grazing systems. We can see that one of the main differences has to do with the amount of methane they produce. So the fully house farms, intensive farms, have a better quality of the feed, generally feed imported to the farms, and that makes enteric methane fermentation be reduced, and the opposite for the grazing systems, where they get most of their feed from the local resources of the farm, and generally they cannot control as much the quality of this feed. If we account actually for the potential of soil organic carbon sequestration, we have a different completely picture. This is the soil organic carbon sequestration, that is not generally accounted for in conventional carbon footprint calculations. But if we account for this soil organic carbon, we would find that some of the extensive farms actually could offset a large proportion of their greenhouse gas emissions. Moreover, if we account for some of this soil organic carbon sequestration at the European level, even for the carbon footprinting, so that's the left graph, we can estimate a much lower contribution to warming, like the one we see here in the left side graph, where impact to warming is shown assuming different soil organic carbon sequestration levels. So in some occasions are equal or even lower than the warming in Europe using only direct greenhouse gas emissions. So to sum it up, my message: European sheep and goats have not caused additional warming to the atmosphere in the last decades from direct greenhouse gas emissions, and a small amount from emissions considered at the whole supply chain. I have demonstrated with new metrics that any strategy towards climate neutrality should consider separating methane from long-lived greenhouse gas emissions and account for soil organic carbon sequestration in pastures. Although I have not mentioned in my presentation, there are numerous opportunities to promote reductions in greenhouse gas emissions at the production level. We can talk about measures helping reduce methane from the rumen, but there are other possibilities concerning the ingredients farmers use in their concentrates, manure management, or even producing renewable energy on the farm. So achieving high environmental and production quality standards should be the main strategy of the sector. This move should be rewarded by either consumers or policies. So with this, I would like to thank you for your attention, and I would like to highlight this YouTube video that we show some of the information that we have presented here in a very nice infographic way.